All right, today we're diving into a tool that literally changed modern biology. We're talking about a search engine, but not for the web. This is a search engine for the code of life itself. It's called FASTA.
So to really get what FASTA does, just imagine this for a second. You're standing in a library, but it's got millions of books, and your job is to find one single sentence. I mean, you're not going to read every single page, right? No way, that would be impossible. Well, that's exactly the problem scientists were facing with DNA. The amount of data is just staggering.
So here's how we're going to break it all down. First, we'll look at the huge challenge of searching the code of life. Then we'll figure out what makes a search good or bad with hits, misses, and false alarms. After that, we'll see how to give it a grade by scoring our search's accuracy. Then comes the really cool part, the high-speed indexing trick that makes it all possible. And finally, we'll see how it all connects.
All right, first up, searching the code of life. Let's really dig into this grand challenge.
You see, our genome, our complete set of DNA, is just like that giant library we talked about. It has billions of letters, and finding a very specific sequence, maybe one that's linked to a disease or a particular biological function, is absolutely crucial for any kind of medical or scientific breakthrough. But like we said, just searching letter by letter by letter, it would take an eternity. We needed a much, much smarter way to do it.
So before you can even think about building a fast search tool, you've got to ask a more basic question. How do we know if a search result is any good? That brings us to part 2, hits, misses, and false alarms. How do you actually grade a search?
To make this super clear, we're going to use an analogy that's pretty high stakes and something we can all understand, a medical diagnosis, let's say for cancer. This is a perfect way to frame how we think about accuracy. This little chart breaks down every single possible outcome. If the test says positive and you're actually sick, that's a true positive, a correct hit. But if it says positive and you're healthy, that's a false positive, a false alarm. Now, if the test says negative but you're actually sick, that's a false negative, and that's a really dangerous miss. And finally, if it says negative and you're healthy, that's a true negative, a correct all clear. Every search result, whether it's for medicine or DNA, falls into one of these 4 boxes.
Okay, so now we have these 4 basic grades, but how do we turn them into a formal report card? That brings us to actually scoring our search's accuracy.
Our first score is called sensitivity. All it is the number of true positives divided by the total number of actual positives that are out there. So, in plain English, sensitivity answers one simple question. Of all the things I was supposed to find, how many did I actually catch? You want a high sensitivity because that means you're not missing much.
And then you've got the flip side of the coin, selectivity. This is the number of true negatives divided by all the things that are, well, actually negative. Selectivity answers the other important question. Of all the junk I was supposed to ignore, how much did I actually ignore? High selectivity is great because it means you're not getting buried in false alarms.
Okay, let's make this super concrete with a quick example. Let's pretend the perfect result of our search for the letter C should be CCC. But our search program isn't perfect. It comes back with ACC. Let's calculate the sensitivity, shall we?
First thing we need is the number of true positives. Well, our result, ACC, has 2 C's in it that are correct, so our true positives count is 2.
Next, we need to know the total number of positives that were there to be found in the first place. The ideal result was CCC, so that's a total of 3.
So you just do the math. Our sensitivity is 2 divided by 3. Our search found 2/3 of what it was supposed to, see? This simple score gives us a really powerful and standard way to measure how well any search is performing.
And now, for the main event. We know how to score a search, but how in the world do we make it fast? This is where we get to the secret sauce, the high-speed indexing trick that makes FASTA so incredibly powerful. Now, the technical name for this is a hash table algorithm, which sounds a little intimidating, I know, but it really just boils down to 4 simple steps. First, we build an index of our search term. Second, we use that index to spot potential matches. Third, we create something called an offset table to score them. And fourth, we find the best match just by looking at that score.
Okay, let's walk through it. Imagine we're searching for the sequence Justice League. The very first thing FASTA does is make a little cheat sheet, or an index. You can see it here. It's just a map. It lists every unique letter and exactly where it appears in our search term. So A is at position 9. E shows up at positions 6, 8, and 12, and so on. Easy enough, right?
Now for the next part. We start scanning through that massive target sequence, in this case, League of Assassins. For every single letter we see in the target, we look back at our little cheat sheet. If that letter is on our list, we do a tiny bit of math to calculate an offset. It's just the difference between its position in our search term and where we are right now in the target sequence. This process just spits out a long list of these offset numbers.
And here is the stroke of genius. Instead of doing some complicated, slow comparison of the two sequences, we just look at that big list of offset numbers we made. And the number that appears most often? That's our winner. It points us directly to the best possible alignment. In this case, the number 7 would pop up 6 times, way more than any other. And boom, just like that, we know the best match is right there. It's such a clever and incredibly fast shortcut.
So let's bring it all home. How do all of these pieces, the grading, the scoring, and the super fast indexing trick, all come together to make FASTA so revolutionary?
The power of FASTA is really in how it combines all these ideas. It uses those principles of true and false positives to grade every single potential match it finds. It scores its own performance using sensitivity and selectivity so researchers know they can trust the results. But the real game changer is that brilliant indexing trick that lets it tear through gigantic databases in seconds, not hours or days. It's this combination of blistering speed and reliable accuracy that made it an absolute cornerstone of biology.
And that really leaves us with one final, incredible thought. We've built a search engine for life itself. Now that we have the power to ask our own DNA questions and get answers back almost instantly, what's next? What new medicines, what new insights into evolution, what other profound discoveries are just sitting there, waiting to be unlocked?